Hi, everybody. I think we're going to get started. So I want to say hello and welcome. My name is Sarah DeFeo, and I'm the Vice President of Scientific Affairs here at Ovarian Cancer Research Fund Alliance. And I want to thank you all for joining us today as we continue our webinar series. And tonight we'll hear from Dr. Elizabeth Swisher with an update on the Ovarian Cancer Dream Team, which is very exciting. Our webinar series has been supported by Genentech, and I want to thank them for the generosity in making this all possible. So just a little background about our organization. In January of this year, Ovarian Cancer Research Fund and the Ovarian Cancer National Alliance merged to form a new organization, the Ovarian Cancer Research Fund Alliance, which is the largest global organization dedicated to the fight against ovarian cancer. OCRFA funds research, advocates for increased federal research and awareness dollars, and advocates for policies that give women access to the services they need, while also supporting women and their families before, during, and after a diagnosis. So before we get started, I have just a few housekeeping notes to go through. So all listeners will be in a listen-only mode throughout the presentation. We should have some time for questions. So if you think of a question while you're listening, you can just type it into the Q&A box that you should see on the right-hand side of your screen. I'll see all the questions, and I'll select some to ask Dr. Swisher at the end of the presentation. So you don't have to wait until the presentation is over to submit questions. You can just type them in as we go along. And I know that some of you also submitted a few questions ahead of time, so thank you. I do ask that you try to keep your questions as general as possible so that the answers will be useful to everybody who is listening. So I'm very pleased to have Dr. Elizabeth Swisher with us here tonight as our presenter. Dr. Swisher is a professor of gynecologic oncology at the University of Washington School of Medicine, where she's been since 1999. And she's the director of the Breast and Ovarian Cancer Prevention Program at the Seattle Cancer Care Alliance. Both her clinical and laboratory work focus on cancer genetics. Dr. Swisher graduated cum laude from Yale University and received her medical degree from the University of California, San Diego. She completed her residency in obstetrics and gynecology at the University of Washington and a fellowship in gynecologic oncology at Washington University, St. Louis. Her research has been funded by NIH, the Department of Defense, OCRFA, and other cancer foundations. And importantly, she has also been a member of the OCRFA Scientific Advisory Committee, where she donated hours and hours of her time reviewing our research grants. So we're very grateful to her for that. So Dr. Swisher, I will pass the mic to you, and you can begin.
Okay, let me get, all right, I'm getting my file. Okay,
great.
So while that's loading, I just want to say thank you, Sarah, and thank you to all of you out there who support OCRFA. The research that's supported through OCRFA is really meaningful. It really is innovative research, it's cutting edge, they're willing to take risks, and it's very translational, meaning it's all research that relates to patients and to people. And they were really the group that, was the initiative behind that kind of got the Stand Up to Cancer, first Ovarian Cancer Dream Team started. And this is an innovative type of research where different researchers are, put a team together that don't normally work together. And my co-leader is Dr. Alan D'Andrea from Dana-Farber. He's actually a pediatric oncologist who's a very renowned scientist in DNA repair. And you may wonder, why is a pediatric oncologist working with a gynecologic oncologist? And this is the type of things that Stand Up to Cancer brings together. And I had never met Alan. I had never even spoken to Alan. When the call for this Stand Up to Cancer team came about, he called me on the phone and said, I'm aware of your work, and would you like to work together? And, it's a very exciting thing that would not have happened without this particular mechanism. So just up front, I want to say thank you, and not leave that till the end, because some people always sign off a little early. So this is our team. What Stand Up to Cancer does is it brings together scientists from 6 different sites. So we have the University of Washington, Dana-Farber, and then University of Chicago, Memorial Sloan Kettering, the Mayo Clinic, and MD Anderson, and you can see my co-investigators there who are leaders at each of those sites. So our team was built, our team has a theme of DNA repair, which I'll talk about in a second, but our team was built on this basic foundation of science working together, team science, supporting two different areas of work. One is on therapy for women who already have ovarian cancer. And another part of the trial, another part of the program is prevention, looking at genetic risk and prevention of ovarian cancer. And this is actually unique to Stand Up to Cancer. There's dream teams for many different cancer sites, but we are the only dream team to include a major prevention aspect, so we're pretty proud of that. And then another really important part of our team is the advocacy. So we have three great advocates that are listed up at the top. Jamie Crace, who's in Washington State, Deborah Polinsky, who's in New York City, and Kathleen Gavin, who's in Minneapolis. And they've been really instrumental. The work that I'm going to show you today, the two trials that we're working on, the advocates have been at our side every day. They were emailing today. They've given feedback on the design of the trial, the specifics of the trial, the patient population to target, every aspect of it, and it's been incredibly useful to have them. So we definitely feel like it's a team effort. So I'm going to so why do we focus on DNA repair? So DNA repair is a really crucial cellular function. As cells divide, they have to replicate their DNA, and invariably mistakes happen in that process as there's billions of bases of DNA, and there's always mistakes that happen, and if the cell doesn't repair them, the cell's going to die. So DNA repair is a very crucial cellular function, and there's many types of DNA repair that the cell uses, and it's sort of a redundant repair pathway because if it goes wrong in one place, the cell has to catch it. So there's a lot of aspects to DNA repair. And if the cell has defective DNA repair, it can then accumulate mutations, which can lead to cancer. So defective DNA repair is a key to development of many cancers. It can also impact the way a cancer responds to therapy because chemotherapy and radiation and even in some of the newer agents or damage the DNA. And that's how they work to kill the cancer cell. And if the cancer cannot fix that damage, it's more likely to die from the therapy. So we can kind of predict how a cancer is going to do with certain therapies based on its DNA repair capacity. And then there's many genes that are associated with DNA repair that actually are also related to inherited risk of cancer. So BRCA1 and BRCA2, which are the most common breast and ovarian cancer genes, are DNA repair genes, as are many of the other genes that we associate with breast or ovarian cancer risk. So a few aspects that led us to work in DNA repair specifically in ovarian cancer is that we know that ovarian cancer has few druggable targets, but up to half of ovarian cancer does have defective DNA repair. And as I said, defective DNA repair makes it harder for the cancer to repair DNA damage caused by chemotherapy. But there's some newer drugs, and specifically PARP inhibitors, that are lethal to certain cancer cells that have specific types of defective DNA repair. And so that defective DNA repair is essentially an Achilles heel for many ovarian cancers, and it provides therapeutic opportunities. So our team wanted to take advantage of that. So there's the program is divided into three big aims. And the first aim is basically science. It's looking at ways that cancers are either sensitive or resistant to these PARP inhibitors. And we have DNA repair experts from around the country who are all together on this aim. And I'm not really going to go into the details of this aim today because I think it'll be less of interest to this audience, but it is a foundation for what we're doing. The second aim, which I'm also really not going to spend time on today, is the therapeutic part. And we have 4 different clinical trials which involve novel drug combinations with PARP inhibitors in an attempt to extend the use of PARP inhibitors beyond women that have BRCA mutations to other women with ovarian cancer and to make these drugs more effective. And then the third aim, which is what I'm going to dwell on today, is our prevention aim. So it's divided into risk assessment and prevention. So I'm going to give you a little bit of background about genetic risk of ovarian cancer. It was really Mary Claire King who is given credit for discovering BRCA1 and for basically discovering that hereditary breast and ovarian cancer is related to a single gene, which was thought to be quite novel when she came out with that. So back in 1990, she identified this, the location of this gene, and with the technology back then, it took 4 years for many scientists around the world racing pretty much around the clock to sequence this one gene. And now, we could sequence all the genes that we have, 30,000 genes in a single day without a problem. So a single person could do that. So it's amazing how much the technology of DNA sequencing has changed in that time. So how much of breast and ovarian cancer is hereditary and which genes are involved? And I can't really talk about the whole discovery of BRCA1, but it's a fascinating story. And I would encourage people in the audience who are interested to watch, to look at YouTube and look up Mary Claire King on Moth Radio, and she gives a really great personal story about a week where a lot of things went wrong in the quest to discover BRCA1, and I think you guys would enjoy that. So why do we care about familial risk? Well, the main reason is that these cancers can be prevented. And I think most of you in the audience know that ovarian cancer is a very deadly disease, and we should not miss any opportunity to prevent a cancer, which is clearly a better way to go than to have to treat an advanced cancer. So our third aim, which is the risk assessment and prevention aim, is divided into 3 areas. First, defining the risk, then breaking down the barriers to genetic risk assessment, and then increasing the options for surgical prevention. So the rationale for this is that we know that about 1 out of 5 ovarian cancers is caused by an inherited mutation in one of 11 different genes. And we know that risk-reducing self-pinged oophorectomy, which is a complicated way of saying removing the ovaries and fallopian tubes, effectively saves the lives of women who have a high risk of cancer. But the problem is that genetic testing is really underutilized. Another barrier to effective prevention is that not all women are willing to undergo removal of their ovaries because it causes early menopause, and women are concerned about the side effects of that. We also know that about 80 to 90% of the ovarian cancers that occur in women with hereditary risk arise in the fallopian tube. And that provides us a unique opportunity to try a different kind of prevention, which I will get into in a minute. So first, a little background on BRCA1 and BRCA2. I told you that they were important DNA repair genes. About 15% of ovarian cancer is caused by mutations in these genes, and a BRCA1 mutation leads to a lifetime risk of ovarian cancer of about 40%, in contrast to the population risk for ovarian cancer of about 1.8%. BRCA2 mutations lead to a 20% lifetime risk of ovarian cancer, so again, very high, and both lead to a high risk of breast cancer as well. They also increase the risk of male breast cancer, pancreatic, and early onset prostate cancer. So olaparib is a new drug that is in this PARP inhibitor category that I already mentioned. It's been approved for use in women with recurrent ovarian cancer who have BRCA1 or BRCA2 mutations, but they have to have failed 3 previous lines of therapy, which is a little discouraging for patients because we would like to use this drug earlier in the therapeutic pathway. So the first part of the aim is to better understand the other genes that cause ovarian cancer risk. So the estimate of risks for BRCA1 and BRCA2 are well established, but we've recently discovered with Dr. King and some others around the country have done the same, that there are other genes in the same family, they're all DNA repair genes as well, that increase the risk of ovarian cancer. not as high as BRCA1 or BRCA2, but about a 8-fold risk of ovarian cancer, and that translates to about a 10% lifetime risk of ovarian cancer, and those genes are listed here. But what we want to do is get even more precise estimates of risk. So we're just understanding that this is a level of risk that we do think preventive surgery is indicated, but what's the right age? We need more data, like what is the exact risk estimate so we can give women the best information possible. So the first part of this study is to look at, we've already sequenced 2,000 women with ovarian cancer, and we want to double that to about 4,000 women with ovarian cancer. We're also going to sequence women that have never had cancer from a study called the Women's Health Initiative, where we know that the women were healthy, they never got breast or ovarian cancer, and we can sequence them as a control population, as healthy women who didn't get cancer, and we can compare the mutation rates in the two groups. And that will allow us to generate a more precise risk estimate for these different genes. It may also allow us to identify new ovarian cancer genes, which are rare but potentially increase the risk of ovarian cancer. So how does this relate to what you can do? So one thing that you can do for yourself and for your family is to know your family history and to share that knowledge with relatives. Know that who got cancer in your family. Ask your mom and your dad while they're still living. Ask aunts and uncles. What kind of cancers did people have? And what matters is, where did that cancer start, not where it ended. So if somebody got metastases that went to the lung or the brain, that matters less than where did the cancer originate. Was it originally an ovarian cancer? Was it a breast cancer? And what age did they get that cancer at? So those are the two things to sort of try to tease out in your family history. And if there's multiple people with cancer on one side of the family, share that information with your physician and potentially ask if genetic testing is indicated. So not everybody's family history is the same. So this one is that Rodney's family tree was a lot shorter than most. You might have a small family where there's not a lot that's known about your family history. And then your threshold for when you get genetic testing might be less. If you have, no information about your father and that side of the family, your threshold for when you would want to get genetic testing might be less than if your dad had 20 sisters and none of them had cancer. So yeah, just to point out, I did mean to say that your father's history is just as important as your mom's history. And just because these are female cancers, they can track down either side of the family. So what are the red flags of hereditary cancer? So early onset cancers, premenopausal breast cancer, usually less than age 50, colon cancer less than age 50, multiple affected relatives on one side of the family, individuals in your family that have more than one cancer, either at the same time, like a bilateral breast cancer, or at different times, two different cancers, or it could be two of the same cancer, rare or unusual cancers such as male breast cancer. These would be red flags that you'd want to discuss with your physician. So what's the rationale then for genetic testing? Well, it identifies accurately risk to patients. It can identify cancer risk to other organs, and it allows for appropriate interventions for those women who are at risk. It also avoids unnecessary interventions for those who are not at risk, so it eliminates uncertainty. So in this pedigree, the circles are girls, and you're going to see more pedigrees in a few minutes. So the circles are women, the squares are men, and in this example, the two shaded in black circles, both these women have had early onset breast cancer, and one had both breast and ovarian cancer. That is suspicious that that there's some genetic link causing cancer in both of these sisters. So their daughters, of course, are concerned about their risk. So genetic testing can help clarify which of these women shaded in pink are at risk and which are not. So if the daughter wants to know her risk, here's another example of a family. You really want to start by testing not the daughter who wants to know her risk, but you want to start, if possible, by testing the person who had cancer if they're still alive and there's a sample to be tested. So in this example, this woman had both breast and ovarian cancer, and these are real examples that I'm using. And she tested negative for BRCA1 and BRCA2. That was before we understood that there were even other genes that can cause these cancers. And so if her daughter then had been tested and had been negative for BRCA1 and 2 and you had never tested the mom, you would not have really known that test was not helpful. The mom didn't have a BRCA mutation, neither does the daughter. It doesn't tell you whether or not she's at risk. In fact, the mom has a mutation in a different gene. This is the BRIP1 gene. This gene is also one of those other genes that I mentioned before that's in a DNA repair gene, acts in a similar fashion to BRCA1 and BRCA2, and explains this woman's breast and ovarian cancer. Now her daughter can have testing, and a positive test tells her she's at risk, and a negative test is really a negative test, whereas a negative test when you don't know what's going on in the family is more uncertain. Okay, so the hereditary risk, as I mentioned, can come from the dad's side as well as the mom's side. And this is often what happens in a family is this woman has ovarian cancer, and she had an aunt with breast cancer. It was on her dad's side. She never thought she was particularly at risk for cancer. But her father has a BRCA1 mutation. He's not going to get ovarian cancer. It's unlikely that he's going to get breast cancer. And so this woman shows up with ovarian cancer without realizing that she was at risk. These are connected through her father. You can also have hereditary ovarian cancer even when there's no family history. So in this example, this woman has fallopian tube cancer at age 52, and she was negative for BRCA1 and BRCA2. And so it was thought, okay, this cancer was probably random then because there's really no other cancers in the family. But when we tested this family, we found that she had a mutation in another gene that's related to BRCA1 called BARD1. And when I called to give her the results, she told me, oh, her sister was just identified with a triple-negative breast cancer. And again, her sister carried this BARD1 mutation. So now we're able to inform all these other women in the family about who's at risk and who's not at risk. The sisters, mothers, daughters each have a 50% chance of having the same mutation. So once you identify that mutation, her daughters or her sisters will have a 50% chance of having the same mutation. And if they're positive, you know they're at risk. But if they're negative, you avoid interventions that are unnecessary. It's also true that gene mutations will not skip generations. So in the sister over here on the right who tested negative for the BARD1 mutation, her 3 daughters are not at risk. It cannot skip a generation. It's also true that you will have mutation carriers in the family who don't necessarily get cancer. This family is an example of 2 women that have ovarian cancer, and then a 3rd woman has ovarian cancer who's separated from those women by 2 generations of women that did not have cancer. So this family, all these 3 women have a RAD51C mutation. For the youngest woman here to have a RAD51C mutation, her mother must be a carrier and her grandmother must be a carrier. I just told you it can't skip generations. But they don't have cancer. Well, we know for a RAD51C mutation that only about 10% of women with the mutation will get cancer. And the risks differ for each gene. So when we look at a whole series of women with ovarian cancer, about 21% of them will have an inherited mutation in a gene that is associated with causing their ovarian cancer. And about 3/4 of that occurs in BRCA1 and BRCA2. But just about 21% of the mutations occur in genes other than BRCA1 and BRCA2. So genetic testing for those other genes has only been around for a few years. And most women who had ovarian cancer 5 years ago, they would have only been tested for BRCA1 and BRCA2. So what are the barriers to getting genetic risk identified? So if we use those family risk factors that I reviewed earlier, we would identify about 2/3 of women who are walking around with a BRCA mutation. But 1/3 of women aren't going to have any clear family cancer history, And so they're walking around at risk without any idea until they actually get cancer. So we know that a third of women with BRCA mutations will have no significant family history until they get cancer. Secondly, primary practitioners and patients tend to under-recognize familial risk factors. So it's really important that you bring your doctor's attention to this. It's just generally not necessarily everybody's first priority when you go in to see your physician. Other barriers to getting genetic risk include the cost of genetic testing, access to genetic counselors, inconvenience of having to go in and see a genetic counselor or a specialist if your physician isn't going to know that much about it, and then a lack of understanding by patients of the potential health benefits to understanding their cancer risk. But what if you could get genetic testing in your living room? Would that change your interest in getting genetic testing? And so this is really leading to our first study, which is we wanted to ask the question, could we change the paradigm for delivering genetic testing? Could we bring it right to women in their living room and create an online experience with access to phone counseling with no requirement for multiple clinic visits? Is it feasible? Does it result in more distress for the patients and less knowledge? Phone counseling is now accepted as being equal to in-person counseling, so that wasn't really the issue. What we wanted to understand was how much counseling is really necessary? How much can we deliver information by the internet and other methods to patients and simplify the process? So we're creating a trial, and it's probably going to open, we hope, in January, which is the goal is to assess how well we can deliver genetic testing for breast and ovarian cancer risk to women in their living room. And our target population is women who've never had ovarian cancer, who've never had genetic testing or counseling, or at least 30 years old, and they either have to have a personal history of breast cancer or a family history of breast or ovarian cancer, and we're going to enroll over 2,000 women like that, or we're going to do something called cascade testing, which is we're going to test family members of individuals who have a known mutation. So if your aunt has a BRCA1 mutation and you've never had genetic testing, you'd potentially be eligible for this trial. And so MAGENTA stands for Making Genetic Testing Accessible. And what we're trying to do is compare a standard approach of genetic testing to variations of online education. And patients will be randomized to either get, the standard arm will be getting phone counseling before the test and phone counseling after the test before you get any results. And then we're going to have variations of online education and skipping the pretest counseling versus online release of the results to the patient and skipping the post-test counseling. Anybody who has a positive test result will get phone counseling with a genetic counselor as a mandatory, but anybody else can choose to have phone counseling at any point during the process. So if the patient is randomized to no phone counselor, they can still click on a button at any point and say, I want to talk to a counselor. And that's going to be interesting information for us to look at the uptake of how much genetic counseling people feel like they need and for what reasons. So what Women's Experience is going to be is we've built these websites. It's being hosted at MD Anderson. And they'll come in and they will learn about, they're going to watch a video that Stand Up to Cancer is helping us make, and it will tell them about the test, about the study, and they'll say, you know, how do I enroll in the study? And then they'll go through an eligibility questionnaire where it leads them through a series of checklists to find out whether they're eligible. And if at the end they're eligible, it provides them an electronic consent, and they do everything they can consent electronically to the study. And then, let me see, sorry. Oh, well, I guess I don't have that part. So then what happens is they if they qualify for the study and they've consented, then they get randomized to one of our 4 arms of variations of counseling. They have to fill out a whole bunch of baseline questionnaires. And then they get mailed a spit kit where they spit into a tube, and then it gets shipped back to a company that does the testing, and they never have to leave their living room, and then they're notified when the results are available. So our primary outcome of interest, meaning what we're really measuring in the study, is whether or not there's an increase in distress in one arm versus another? Does having less counseling increase the amount of specific worry that patients have about their cancer risk? And, you know, then the other things that we're going to measure are how satisfied are they with the services? Is it causing anxiety or depression? Are they happy that they chose to get the test? And then how do they use that information? Do they understand the information? Are they communicating it to family members? And are they utilizing that information to change their ovarian cancer screening or prevention behaviors? Okay, so that's our genetic testing piece. So that's kind of our middle piece. And then our third piece is the actual prevention itself. So not all women want preventive surgery. And so the main reason is that having your ovaries out before menopause puts you into what we call surgical menopause. And that has a negative impact on health, on sexual function, and on well-being. And I think you can see here in the cartoon, she's saying, listen, buddy, after the hot flashes I've been having, this is like a resort. So we can give many of our women estrogen replacement therapy and improve the hot flashes. But one of the major complaints that women have, and one of the reasons that is passed around at least on the internet and in support groups as being a negative impact from having your ovaries out for prevention is a potential impact on sexual function. So what alternatives do women have to that besides just crossing their fingers and hoping they don't get cancer? So we actually have learned in the last decade that many of the ovarian and peritoneal cancers, particularly in high-risk women, aren't starting in the ovary at all, but they're starting in the fallopian tube and then seeding the ovary. So the fallopian tube is in close contact with the ovary, and cancer cells start out towards the end of the fallopian tube and then spread out easily, and the ovary is a very receptive place for those cells to grow. So if the fallopian tube is the source, is it possible that we could just remove the fallopian tube and keep the ovaries? And so this has been bandied about as a potential way to do prevention with less impact on the patients. And it really could be useful in two groups of women. One is the group of women who are too young to have their ovaries out, but they are done having their children. So they could get an extra benefit of they're ready to give up their fertility, take your fallopian tubes out, get some prevention, and then get your ovaries out down the road. And then there's a group of women who are delaying getting their ovaries out beyond our recommended age for whatever their genetic risk is in order to avoid menopause. And in those women, we feel like, well, we know that getting out the ovaries and the fallopian tubes is effective, and that's our recommendation currently. But if they're unwilling to do that, then we think getting the fallopian tubes out is probably better than doing nothing at all. So MD Anderson completed enrollment of a pilot trial of about 40 women, and we call this ISDO. This trial was originally called WISDOM, but the human subjects review, they thought that calling it WISDOM was coercive, meaning if we call it WISDOM, it's like implying that the wise choice is to only take out your fallopian tubes. So now the trial is called WISP. So sorry that I didn't fix that on this slide. But interval self-injectomy with delayed oophorectomy is what we call ISDO. So that means the patient needs two different surgeries. First take out the fallopian tubes and later take out the ovaries. And that interval is kind of up to them. So because we know that taking out the ovaries and the fallopian tubes is safe and effective for women who are high risk, we wouldn't randomize people. We wouldn't make people undergo 2 surgeries compared to our standard surgery. And so this is not a randomized trial. It's a trial where women come in and they make their own choice about what it is that they want. They can choose to have the standard, take out your ovaries and your fallopian tubes in a single surgery, or they can choose to have an interval self-injectomy where they just take out the fallopian tubes and then come back for a later surgery where they do a delayed oophorectomy. And so women have to be 30 to 50 to go on this trial. They have to be premenopausal. They have to have a known mutation in an ovarian cancer gene. And our primary outcome is sexual function, change in sexual function, actually, for before surgery to after surgery for individual women. And the reason we're choosing that is because that's an important, outcome for women. And we really don't have enough. It would take more than 2,000 women to do a study where we could have enough what we call power to identify if there's a difference in cancer between the arms. So cancer is obviously our primary development of cancer is our primary thing that we want to measure. But we want to at least start with a trial to show that it's feasible and define whether or not there's a difference in sexual function between the women that are choosing to keep their ovaries for a longer period of time. And so the six sites that are going to have this trial are listed here, and they're the 6 sites on our Stand Up to Cancer team. So that includes the University of Washington in Seattle, MD Anderson in Houston, Memorial Sloan Kettering in New York, Dana-Farber in Boston, and University of Chicago in Chicago, Mayo Clinic in Minnesota. So it's open at MD Anderson in the Mayo Clinic right now. It's going to open at the University of Washington next week, I believe. And it's in process at the other 3 sites at various stages of getting open. So women, some women can travel from out of state or whatever who are very interested in this trial. We certainly welcome that. It's not paid for, so if people come from somewhere else, they're sort of on their own. We're definitely operating on a shoestring budget. We're trying to make any research dollars go as far as possible. So basically, in summary, this aim is to define ovarian cancer risk better, to reduce the barriers to genetic risk assessment, and to improve options for surgical prevention for high-risk women. And I just want to emphasize again that advocacy to developing this has been very critical. Our advocates have contributed to clinical trial design, to recruitment, to interpretation of results. And now that the trial is opening, our advocacy partners like OCRFA, we hope to help us publicize that the trial is open, and when we have results, we want to publicize those results to patients and providers so that they can be useful to high-risk women. And so I'm just going to conclude again by thanking you for your patience through this, and thank you for your support of ovarian cancer research and of the OCRFA. And I want to thank my co-investigators and our Stand Up to Cancer team for helping me get this far along. So that's it. Thank you very much, and willing to take questions.
Great. Thank you so much, Dr. Swisher. So just as a reminder, if you've got questions, some of you have been asking them, just type them into your Q&A box on the side of the screen. Okay, so to get started, let's see. So the MAGENTA trial, question is that currently enrolling?
The MAGENTA trial is not yet enrolling. It's in its second pass through the human subjects review, so we're hoping that it will be approved or close to approval in the next month, but we're still doing testing of the website to make, what we don't want to do is enroll patients and have them get stuck in the process. So we're doing usability testing right now, and there's also a few legal things being worked out about data transfer and stuff like that, and so we're pretty confident that it'll be open by January 1st.
Great. This question was asked specifically about the MAGENTA trial, though I think it could sort of apply to either trial. Are there efforts being made to ensure that there's a diverse group of women enrolled in these trials so that minorities are represented?
Yeah, so that's a great question, and really one of the reasons we want to try to break down the barriers to genetic testing is that genetic testing is quite underutilized and underserved women, and that includes both minority women and women in rural areas. You know, a lot of the genetic counselors right now are centered at big cancer centers, which are centered in urban areas. And so access to genetic testing and understanding of genetic testing varies across these groups. And so, yeah, we want to particularly, I think we're going to be using some novel advertising to try to reach certain demographic groups. So we are going to be advertising on Facebook and through social media, and there you can target certain groups. We can also target, you know, certain magazines and things that appeal to certain subgroups of the population, but particularly like doing Facebook ads, you can target a certain population, and then we can watch in real time whether we get a bump in our enrollment from that population. So we might target a certain like rural area in the South or something where we're not getting much uptake of enrollment, and then we can see if does that work? And that itself, honestly, is somewhat novel and will probably be a research paper on its own, is how do you access those underserved populations, and is social media a way that we can do it? So that's true for MAGENTA. I think for WISP, I mean, it's a little bit harder because women have to have already had genetic testing and have a genetic risk identified. So if underserved women are not getting genetic testing, they're never going to get the WISP. And so really, I think one of the emphases is to break the barriers down to getting this genetic information to underserved women.
Thank you very much. This is just a short question, but how were the sites selected? Someone was asking, you know, why aren't there any sites in California? How were those trial sites selected for WISP?
Well, so those are our 6 sites that are part of our Stand Up to Cancer team. And when Alan and I said, you know, so the way Stand Up to Cancer works is you can only have 6 you know, academic centers working together. That's basically the sort of the rules for putting the program together. And so what we wanted to do was pick the people we wanted to work with who had the strengths in the area of DNA repair therapy and of prevention. So part of it was picking the investigators, and then you're basically married to their site. And part of it, though, is we do want to have sites that are able to enroll well to clinical trials. So you want both. So you want somebody, because we can't then just add a site. And so if somebody is the greatest DNA repair scientist in the world, but they work at a very small center and that center wouldn't be able to enroll many patients to our trials, then we're gonna lose out there. So we used a balance of the people that we really wanted to work with on our dream team and the cancer centers that they represented. And we did want some geographic diversity. So we don't have one in California, but we at least have one on the West Coast. You know, we have a couple on the East Coast, and we have a couple in the Midwest and one in Texas. So we have relative geographic diversity, which was a goal.
Great, thank you. Sort of a general question. So if you mentioned people can be at risk without being BRCA positive, and you talked about these other less prevalent gene mutations that can put people at risk. So for someone who's tested negative for BRCA1 or 2 mutation, do you recommend that they go back and get tested for other gene mutations? And part 2, for someone who has not yet been tested, do you recommend one of these multi-gene panels to try to identify other ones?
Yes, I would never get BRCA1 and 2 testing on its own anymore. So I think BRCA1 and 2 testing is not cheaper than testing for a panel of all the known breast and ovarian cancer genes. So you would think, oh, well, what would you want to spend all that much extra money? Actually, now with the new technology, it doesn't cost more to add new genes. So if you're going to get a test, your insurance company, if you qualify for testing, your insurance company is probably only going to pay for it one time, and then you want to get as much information as you can. So I would get a panel that had multiple genes on it. The first part of the question was, what if you already had BRCA1 and 2 testing? So either that's just the test that you got, either because other tests weren't available or we didn't know as much about them. Then should you go back and get tested? And I think that depends on what we call the pretest probability, which means how likely are you to be positive? Is it worth doing the test at all? So if you're an ovarian cancer survivor, the chance of being positive for BRCA1 and BRCA2 is about 15%. The chance of being positive on one of these other genes is about 4%. So it's 4%. Is that enough? Is that worth it to you? Do you have any family history that's suggestive? If you have a family history that's particularly suggestive, then your risk may be higher than 4%. So part of that is just sort of understanding and talking with a genetics expert about how much extra bang are you going to get for additional testing. Certainly if you have a very suggestive family history. What about if you're not affected by cancer, but you have women with breast cancer in the family? Well, BRCA1 and BRCA2 are just a chunk of your risk. So if you got a negative test result back and now you're going to walk around saying I'm not at risk, then wouldn't you want the most negative test, the best negative test that you could have? So there is a company, and we're actually partnering with them on MAGENTA, called Color Genomics. And Color Genomics offers all the known breast, ovary, and colon cancer genes for $249. So, and I get no money from them, so it's not, this is not an ad for them. But for $250, you know, a lot of times if you've already had BRCA1 and 2 testing, your insurance doesn't want to pay for more testing. But for $250, maybe it's worth it to you. And so part of that is sort of figuring that out, maybe talking with a counselor to get more information.
Thank you. That's extremely helpful. You have mentioned 11 genes. Do you think that there's a chance that with additional research, even more genes will be identified?
Yes, but we find the most common things first. We call that the low-hanging fruit. So the reason BRCA1 and 2 were discovered is they were causing breast and ovarian cancer in the majority of families that had breast and ovarian cancer linked. And each gene we subsequently linked to ovarian cancer is either going to have a lower risk, so it wasn't as obvious, or it's going to be very rare, like BARD1, which I showed you one of the families with BARD1. There's just, you know, a couple dozen families that have been reported in the whole world. So we will discover more, and you could say, well, should I wait and get more testing for another year or two? And we've probably discovered the biggest chunk already, but we will discover a little bit more, but there'll be sort of a smaller and smaller fraction of the total amount of hereditary ovarian cancer risk.
Okay, great. Here's a question. Lots of questions about this stuff. If you do have a BRCA mutation, is it possible that you might have one of the other mutations that you mentioned? And if so, does that sort of compound your risk and put you at an even greater risk?
Yeah, that's a great question. So it is always possible to have another mutation in another gene. And I think if you have a family history that doesn't quite fit, say you have a BRCA2 mutation, but there's a lot of people that have colon cancer in the family. Colon cancer isn't really part of BRCA2 risk. So maybe there's two different things going on. Or there's risk on your dad's side of the family where the BRCA2 is, but there's a lot of cancers on your mom's side of the family too. It's quite possible for two things to be traveling in the same family. So, you know, again, you can get additional testing to sort it out, but the second part of the question is, does that really compound your risk? Generally not, like if it's sort of the same patterns of cancer. So we've seen women with BRCA1 and BRCA2 mutations, and their risk isn't double or triple or really elevated over sort of the worst risk. Like BRCA1 has the highest risk of ovarian cancer. If you have a BRCA1 mutation and a BRCA2 mutation, it's not higher than just having a BRCA1 mutation in the first place. But if you have a risk in a gene that has a different cancer profile, so you have a mutation in a colon cancer gene, well, then that is adding to your total cancer risk because now you're also at risk for colon cancer.
Right. Got it. Okay. Question, when do you suggest that, what's the youngest age that you would suggest someone who is worried about their risk of ovarian cancer be tested? Say, someone whose mom has ovarian cancer, when would you recommend that she be tested? Any sort of guidelines?
Generally, we recommend testing around age 25, and the reason for that is if somebody has a hereditary ovarian cancer risk, they may well have a hereditary breast cancer risk, and if somebody specifically has a BRCA1 or BRCA2 mutation, we start breast cancer screening at age 25. So before age 25, we're certainly not taking out anybody's ovaries at age 25, but we would be initiating breast cancer screening. So it's at that age where it would change medical care. We will not test anybody under age 18 because it doesn't impact their medical needs as a young person. And we want people to be able to make their choice. But when people come at 18 to get tested, often 18-year-olds really aren't that interested. And it's usually the mom who's like, they want to know whether they've passed it on to their kids, so they're anxious to find out. But, you know, we often tell people that are 18, 19, you know, it's not going to change anything that we do right now. If you want to know, you can. You have the right to, request being tested, but it's not going to make any impact on what we do until around 25.
Got it. Okay, thank you. So switching gears a little bit, we have questions about PARP inhibitors. First question, which I thought was an interesting one, was, are PARP inhibitors an actual chemotherapy? So could you talk a little bit about the drug and the way they work?
Yeah. So we don't consider them chemotherapy in the traditional sense of the word. We consider them in the category that we call biologic agents or targeted agents. And a targeted agent is a drug that works in a specific pathway in the cell. So PARP inhibitors work by specifically inhibiting DNA repair pathways. And the reason that they work better in cancers that have BRCA mutations is those cancers already have defects in DNA repair. So now if you attack DNA repair at another level with a PARP inhibitor, those cells are very sensitive. But if cells had normal BRCA function, they would be resistant to the to the PARP inhibitor. So we call those targeted agents, and there's many, many classes of targeted agents now, and the PARP inhibitors are sort of in a bigger class that we are calling DNA repair agents or DNA repair therapies.
Okay, great. Thank you. Can you talk a little bit about how PARP inhibitors work, or what their promise is for patients that aren't BRCA negative, or BRCA mutation positive, rather?
Yeah, so this is an area we're very interested in, which is, so for cancers that don't have a BRCA mutation, they can still have defects in DNA repair. But if they don't have a BRCA mutation, then how do we identify that? If they have defects in repair, they may still respond just as well to PARP inhibitors. So one is looking at these other genes. So we've done a lot of that work, and I've been running a clinical trial where we're actually looking at the predictors of PARP inhibitors response in women that have ovarian cancer but don't have a known BRCA mutation. So there's different ways to sort of try to measure DNA repair. You can measure, you can try to actually measure the repair in the cell, or you can look at mutations in related genes. You can look at sort of characteristics that suggest the cell would have defective repair. And the best way of identifying the women who are going to respond to PARP inhibitors, separate from having a BRCA mutation, is not defined, but it's a very active area of interest right now, and an area that we're making progress in. So that's one group of women who can still benefit from the PARP inhibitors. And the second group is, it may be that we can take a cancer cell that has normal DNA repair and would not normally be sensitive to a PARP inhibitor, and we can sensitize it to a PARP inhibitor by using another DNA repair drug that makes its DNA repair defective in the cancer cell. So take a cancer cell and make it go from being good DNA repair to bad DNA repair, and then adding the PARP inhibitor now is going to work. So we're looking both at predictors of who will respond to PARP inhibitor and ways of combining the PARP inhibitors with other drugs so that we can make more different cancers sensitive to them.
Great, thank you. Okay, you've answered a lot of questions. Maybe this will be our last one. And this is, again, changing gears, but it was an interesting question, and I think maybe one people would be interested in hearing your perspective on. So ovarian cancer screening, we know that there's evidence that shows that screening for ovarian cancer is not effective. Someone asked a question about the ROCA test, which has been in the news and which we know the FDA made a statement about, and the company that makes the ROCA test has now pulled it from the market. What do you recommend, if any, action, what action, if any, would you recommend a woman take who is concerned about getting ovarian cancer and wants to do anything she can to try to catch it early? Tough question.
So what I would suggest is getting genetic testing, because so for women who have, family histories, the most important thing is to define your risk as much as possible, because, for a lot of things, if you have a really high risk, you might remove the organ. So say you have a very high risk of breast cancer, you might have a mastectomy. But if you had an intermediate risk of breast cancer, then you're just going to do screening. And so for women who have a little bit of family history or just kind of a concern, you might say, okay, they're not high enough risk to warrant surgery, so screening is the next best option. But as you mentioned, screening is not particularly effective for ovarian cancer. So what we really want to identify is, what is your risk? As much as we, is your risk high enough to justify, having your ovaries out and going through that surgery, or, you know, are we reassured by your genetic testing that you're sort of in the normal population pool of risk and, you know, probably should worry about other things like getting your colonoscopy and stuff like that. So genetic testing can help, I think, you know, help define where you are in that continuum.
Okay, thank you. That's very helpful. Okay, I think we will wrap it up. Thank you, Dr. Swisher, for a great presentation and for answering so many questions. And thank you, everybody who called in, for your really excellent questions. People have been asking, yes, a copy of this presentation and all the audio will be archived on the OCRF website. So we will send you all a link to that when it's up and ready, probably tomorrow. And also, some of you are asking, you know, how will we know when the MAGENTA trial is open? We follow very closely what's going on with the DREAM team, and so when that's open, we will let you know. So if you're on Facebook, follow us on Facebook, and we will keep you all in the know. So thank you all again. Please take a minute to fill out the survey that will appear on your screen at the conclusion of the event. Your feedback is very helpful to us, and it helps us put together future webinars. So, and for more information, you can always visit the OCRF website at ocrf.org. We will be launching a brand new, shiny OCRF-A website by the end of October, so stay tuned for that. And that's it. Thank you so much, everybody, and have a wonderful evening.
Thank you, Sarah, and thank you, everybody, for hanging in here and asking such great questions.
Thanks, Dr. Swisher.
Okay, bye.